Let's take a quick look at the following example. Suppose that f of x is equal to negative 5x minus 80, where f of x is equal to y. And we want to define f inverse. Now, given what we have, we know that y is equal to negative 5x minus 80. Now, if we do a little algebra, we can solve for x. So first of all, we'll add 80 to both sides, so y plus 80 is equal to negative 5x. And then we can see that x will be equal to y plus 80 divided by negative 5. Now, the reason we might do this is because we know that f inverse takes as its input a value of y and outputs the corresponding value of x. But when we're writing this function definition, we want to express f inverse of y in terms of y. But we know that x is equal to y plus 80 divided by negative 5, so we can continue our equation and write this equal to y plus 80 divided by negative 5. So we know that f inverse of y is equal to y plus 80 divided by negative 5, which in this case, for me, would be the first answer. Now let's look at one from the next question. So let's let h of d equal 5 times d plus 2, where h of d equals s. And this equality right here is telling us that the input to h is d, and the output is s. This basically just tells us the independent and dependent variables. And let's write a formula defining h inverse. First of all, we know that h inverse will take as its input the output of h. So if we look at h, the input is d and the output is s. So h inverse will take input of s and give us an output of d. Now, given our function formula for h, we know that s is equal to 5 times d plus 2. We can solve this equation for d, so let's do that now. First, we'll divide by 5, and then we'll subtract 2. So s divided by 5 minus 2 is equal to d. So if we go back and look at our formula for our inverse, we know that h inverse of s is equal to d. We know that d is equal to s divided by 5 minus 2. So in this case, s divided by 5 minus 2 is our rule for h inverse.